So one of the most useful things about using matrices is that we like to use them to solve systems of equations. So earlier on this year, we solved two equation systems. We also solved 3 variable and 3 equation systems. So you could actually keep going. We could have 4 variables and 4 equations, or 5 variables and 5 equations, or even, I don't want to say an infinite amount, but you could have a whole bunch, and that does happen in really upper level math, okay? And even though we are capable of doing it algebraically, think of how much work it was just to solve one of these, okay? If you remember, we either used substitution or elimination. You had to do all this stuff. Well, the thing is, setting it up in a matrix can make it a lot easier. So that's the first thing we do, is we put all equations in standard form. Okay, so that means x, y equals a number. So on this one, I would have to add the z over there. That would give me 2x minus 7y plus z equals 0, since there's nothing left on that side. I do the same thing here, and you can move it either way. Like if I was going to do this one, I'd probably just subtract the y over here and put the x's on this side. You can rewrite it on either side as long as you keep all the signs consistent. I almost forgot my z. X plus y plus 2z equals 6. Okay, notice I subtracted that y over. And this one, luckily, is already in standard form. Okay, so again, if we were going to solve this algebraically, it would either be substitution or elimination. Probably would want to use elimination since I set it up this way, but it's not going to be easy and it's not going to be fun. If you set it up in a matrix, you lose some of the variables, but as long as you keep everything right, then you're good to go. So lots of times, and there's a couple different ways that they'll do this. They'll just do this half, the 2, the negative 7, and the 1, the 1, the negative 1, and the 2, the 3, the 3, the 3, and they'll say that this, which if you notice is all of these coefficients, times, and then they'll write it like this. They'll put the x, the y, the z. And if you remember what we do with multiplications, if you do this row times this column, then that will be a 2x minus 7y plus 1z. Okay, so that this is one way they'll do it, and then they'll say equals, and then they'll just put the equal stuff over here, the 0, the 6, and the 6. Okay, so this is one way you could see a matrix set up. And again, using this, we can just drop the letters in between and just deal with the numbers to find your answers. So that's what I'm going to kind of do here. 2, 1, 3, negative 7, negative 1, 3. You don't necessarily need to write this in between step. You can go straight from your equation to your matrix. Okay? And so we have this, I don't know, it's a process, I guess, that helps you solve this matrix, and it will tell you your solutions for x, y, and z. Okay? It's called, technically it's called reduced row echelon form. Okay, yeah, just go ahead and remember that, reduced row echelon form. And the way we do that is we start by trying to simplify this number into a 1. Okay, and you do different matrix row operators. For example, if I want to turn that into a 1, then I could go through and divide all these by 2, and that would give me a 1 right there. Okay, you could also, if you didn't want to do that, you could also just switch row 1 and row 2, and you would have a 1 there already. After that, you use different combinations of rows to simplify it, where once you get a 1 here, you turn these 2 into zeros. After that, you try to get a 1 here, and you turn these 2 into zeros. You get a 1 here, and you turn these 2 into zeros. You get it to where you just have 1, 1, 1. Everything else is zeros, and your answer is down here on the last thing. So this is something, I had to do this in college algebra by hand without using a calculator. It's not difficult math. It just really requires you to stay organized, kind of like solving the system does anyway. But luckily for you, I am going to show you how to do this on a calculator. So really all of this matrices stuff we can be done on a calculator. And it's what computers use all the time. So computers use these types of things to solve different equations and stuff like that. When you're programming stuff, you're using different like coding type things. But the first thing we're going to do, and this worksheet right here just walks you through the entire steps to make the calculator solve this system for you. First thing you're going to do is you're going to go second matrix, okay? This gives you different matrices. You have to put in the elements of it. So right now, all of these are empty. If I come over here to the edit and hit enter, then I can enter my own matrix. In this case, this matrix is a 3 by 4. So I'm going to type a 3 and a 4, and then I'm just going to enter each of these elements here. So if I hit the 2 and I hit enter, it's going to automatically bump it over. So that's why I just go down each row. So 2, -7, 1, 0. And I'm pretty fast at this. I've been doing this a while, so I'm sorry if I went too fast for you, but basically I just enter each of those elements. Okay, and that's what it says. Enter the coefficients of your variables. For your variables and constants, each row represents an equation and each column represents a variable. So it's very important all the equations are in standard form, step 1. Step 2 is also if you have any missing variables up here, like notice we didn't have a constant there, I have to put a 0 for anything that's not there. So if this was even like 2x plus z equals 0, I would also need to put a 0 there for the y. You can't have any like open spaces. You got to have every part filled even if it's with a 0. Okay, after you get this matrix entered, you're just going to quit. So quit is a pretty handy thing. You should know how to do that on the calculator. It's second mode. We'll just quit whatever you're doing. If you've been graphing, you can just quit. After that, we have to go back to our, so all we've done is we've put that matrix in the calculator. Now we have to go tell the calculator what to do with it. So again, following the steps, I go back to matrix, but this time I go over to the math menu. The math menu gives you a lot of different mathematical things, mathematical operations you can do with matrices. I'm going to scroll all the way down to the one that says RREF. That's reduced row echelon form. I hit enter. So right now you've told it what to do, but you haven't told it what to do it to. So I have to one more time go back to matrix, hit enter on the matrix A, so it knows to do this to the matrix I just built. I'm going to have to hit enter one more time to make it actually do my operations, and I get an answer that looks like this. Okay, you notice that matches. Again, we've got those zeros all the way down the diagonal. That should happen, and these are your solutions. So looking here, okay, now this tells me this, that when I have all of this times the x, y, z equals this. Okay, and if you look at that, again, if you do this times this, you get 1x, 0y, 0z equals -2. In other words, x equals -2. Okay, same thing. If you do this row times this column, you get 0x is 1y, 0z's, so y equals 0, and again, z equals 4. So this last column there tells you your solutions, and specifically in order. Whatever the first letter you had here was, that's what that one is. So if this was A, B, C, or whatever, or even if you'd put your z's first, then that would be your z solution. Okay? So a couple things, and you could also, we did this last time, write this as the point, 0, 4, okay? A couple of other special cases. So 2 special cases. We do have infinite solutions and we have no solutions. On a no solution case, okay, again, it's going to start off very much the same. This could be any number. Sometimes it's a 0. It just kind of depends. And you'll do okay here. You might even get a number here. But on the very bottom, you'll get 3 zeros and a 1. Okay? These zeros, that means you didn't really have enough, I could talk to you about independence and stuff like that, but you didn't have enough information to be able to figure out that last one, and so there is no real solution here that you can identify. So notice that, and sometimes, like I said, sometimes these are zeros, sometimes they're ones, but this bottom row is going to be 3 zeros and then a 1, instead of the 1, 1, 1. Okay? An infinite solution case is kind of similar. Again, that could be a number, sometimes it isn't. That could be a number, but the very bottom row will zero completely out. So all zeros on the bottom, infinite solutions. 3 zeros and a 1 on the bottom, that's no solution. And 2 zeros, a 1, and a number, or a 0, is going to be, you have a solution. What is it? Okay, so we're going to use this calculator to solve some of these. I just feel so bad that I made you do them all by hand a long time ago before I showed you how to use this calculator.